Okay, good afternoon. Good afternoon to this online session. On behalf of the Erasmus Virtual Exchange Program Impact, and also the Athena European University and Hellenic Mediterranean University. On behalf of all these organizers, I would like to thank, first of all, Web2Learn for the suggestion of Ms. Sofia Terzi in order to provide these workshops in blockchain. This is a series of lectures, workshops that we are going to provide in digital tools, starting from micro-credentials last week. Other, workshops, they are coming, and we will announce it through the Impact website and also through the Athena European University website. It's a great pleasure to welcome today Sofia Terzi, who holds a bachelor degree in computer science and a master degree in information and communication technologies. She's right now a PhD candidate at the Aristotle University in Thessaloniki in e-government. So it's something of a high priority of the current also Greek government, the digital transformation of everything that we are doing in Greece. And, this is also a European priority. Also, she occupies the position of a computer scientist at Web2Learn, which is Web2Learn is a private company, an SME, that collaborates as a full partner in the Impact project. A few words about Sofia. She's experienced software analyst and trainer, skilled in blockchain architecture and analysis, smart contract designs and development, software development, system and database analysis and development, and also technical training regarding related tools. She has participated in the Horizon 2020 projects. She has been involved in blockchain education and other kind of projects related to digital tools. I will provide the floor to Sofia in order to start up. Sofia, thank you very much for your contribution. We really appreciate your contribution. And of course, again, thanks. I would like to express, my gratitude, to Web2Learn for this introduction. The floor is yours, Sofia.
Thank you very much for this invitation. It's great that Web2Learn can contribute to this webinar, and I'm very, very happy to provide an initial introduction to blockchain technology, and even more an introduction to blockchain technology used in education. I will share my screen now so you can see also the slides. Let me know if you can see the screen and if everything is okay.
We can see your screen, yes.
Okay, great. So today our workshop, and that's why we're saying that it is interactive. It's not a webinar. I don't want to be here just speaking all the time. You can also interrupt me anytime, ask any question, add any comment at any part of this presentation. It's a discussion more than a presentation. So we will talk about blockchain in education and how blockchain can enhance the transparency and accredibility in the education domain. Just to provide with an outline of what we are about to see is, first of all, to define what blockchain is. I don't know all the backgrounds of the people here, but it is crucial to have common terms when we speak about blockchain. So I will make an introduction about what blockchain is. And then we can delve more into the use cases where blockchain is important to use. And finally, we will see the education implementation of blockchains and the project that we have been involved as Web2Learn. This project was called Blockademic, and it was about blockchain in the academic domain. So in higher education, but not only, also in lifelong learning institutions. If time permits, then we can delve more into the Hyperledger blockchain technologies. I will make an introduction of these throughout my slides because it is important to understand what Hyperledger is. And it is, of course, a technology supported by the Linux Foundation. And these technologies are for business, because what we will see in the next slides is that blockchain can be used in many cases. We started with the finance domain, but now we are moving into the business domain, in every kind of business domain. Starting with blockchain is first to define what distributed ledger technologies are. So blockchain is part of the distributed ledger technologies, which include a distributed ledger. And by saying ledger, just keep in mind that we're speaking about a database, so you can understand what a ledger is. So it is a distributed database for now. I'll explain a little bit about the ledger later. Which resides across multiple computer devices. So this database is not stored centrally, but it is decentralized and stored in many computer devices, which we call servers in terms of computer science. And it is generally spread even across locations or regions or even worldwide. So the distributed ledger technology includes the blockchain technologies. Blockchain is an implementation of distributed ledger technology and includes only the smart contracts. With smart contracts is a term that we will delve more into the next slides, but I want to mention here two things that are important. First of all, smart contracts is not necessary for the blockchain. We have blockchains version 1. Everybody will know Bitcoin or will have heard of it. And everyone has heard also for Ethereum. So Bitcoin was blockchain version 1, which had to do with finance domain, and also it had cryptocurrencies. This version 1 blockchain didn't have smart contracts. I will explain smart contracts later. Ethereum also entered the domain of version 1 blockchains with cryptocurrency exchange, but then it moved on adding business logic, and that's what smart contracts are. It's business logic. So through the first version of cryptocurrencies, what we can do is exchange crypto assets, and not assets in general, tokens, crypto tokens, so money in the digital world. Now, through the smart contracts, we can exchange everything that can be an asset. Let's say even a house or intellectual property or whatever you can think of, it can be exchanged through smart contracts. So smart contracts are business logic implemented in terms of computer science through functions. And functions is a set of instructions to a computer, so it is a computer program that implements specific actions for something that we want to do as a business action. For example, if we want to send an email, let's say, and it is implemented as a computer function. What it says, the function, that you have to enter the address of the recipient, you have to add the subject, and then maybe some content and send it. So all these steps that you have to follow is what we call in computer science a function. Smart contracts is exactly like that. So it is steps that must be followed in order to execute something on the blockchain. And the blockchain is a network of computers. So you can imagine it as any other network that you know, apart from that it has servers that hold a distributed database. And you will understand it better later. So I will move forward and come back to that if it's needed. All the distributed ledger technologies has a specific data model. This means that we have a specific record type that we add there. In education, for example, we might have a record that represents a student. So the data model, if the name goes first or last, if we will include the middle name or not, this is a data model that we have to follow in order to store this information. The data structure, and also the data model has to do with validation of the structure of the information that has to be stored in order to be stored. And I will say a few things later about that. It also has specific languages. In the beginning, there were computer languages that were specific to the blockchains, but now you can program blockchain in any mainstream language, like Python or JavaScript or whatever. And also there is a protocol that is used for consensus. And when we say consensus among participants here, we mean an agreement. So every server or if you want to have it in your mind, every organization that participates in a blockchain network has to agree in order for a record to be recorded on the blockchain. So in terms of blockchain, the records that are used in databases are called transactions. Whenever you see the word transaction, think of it as a record. And whenever we say consensus, we mean that all the participants, all the servers that participate in the network must agree that this is a valid record and can be added on the immutable ledger. Another important thing is that every record has a timestamp, that it is a peer-to-peer network, and we have shared computational power, cryptography, and consensus, but next slides explain this better. Here we can see a definition of blockchain. I want just to point out that this definition comes from the hyperledger.org, and I just mentioned that because it mentions smart contracts, which are not part, as I've said, of version 1 blockchains as Bitcoin and as Ethereum. So when we speak about blockchain for the business domain, and education is a business domain, we speak about a peer-to-peer network, so computer to computer. Every computer interacts and communicates with each other on the network. A distributed ledger, what means a database that is stored on every server that participates on this network. And it's forced by consensus that they have to agree that this transaction is valid, is legit, and can be added on the blockchain. And this, in terms of business blockchains, is combined with a system for smart contracts. So smart contracts, what are they? As we said, computer programs that execute predefined actions. The predefined actions have been already agreed before, have been written in this function, in this smart contract. The smart contract relies on the ledger, on the blockchain, and it cannot be changed. I will explain that a little bit later, why not. And when these conditions are met, then we have a valid transaction. For example, you can say that when the student finishes this course, they will have earned 30 ECTS. When you say that, this is an agreement between you and the student, and if the condition of the student finishing the course is okay, then these ECTS are written on the blockchain, and the student owns these ECTS. I'll speak about consensus and will say a few words later. In order to have smart contracts and blockchain in general, we must have at least two parties. So blockchains are not the best solution or even a solution if you just have a company or an institution or a university and you want to have immutability. You at least have, you must have two parties, and we will see later which blockchain to select. That have some agreements to make between them. So you create what we call DApp. DApp is what you heard in previous programs, applications, because these applications change decentralized ledgers, decentralized databases. They called DApps. So decentralized applications are the applications that can act on the blockchain ledger and make changes on that ledger. The languages that they use, as I've said, can be anything like Python or JavaScript or whatever. And also, I've said about the consensus algorithm. So consensus algorithm ensures that the ledger has the same information for all the nodes. No server, which we call node, no server can hold information that is different from another one. So the information is redundant per node, per server, but this is something that we want in case of a blockchain. This can prevent the same information in all servers, the malicious actors from manipulating the data. And we will say a little bit later some information regarding malicious users and what can be there in order to prevent them from acting maliciously on the network. For you, most well-known consensus algorithm is the proof of work, and you know that it is energy consuming. So this is the consensus that was followed during the Bitcoin and Ethereum implementations. And proof of work needs very much energy. But when we speak about business blockchains, like the Hyperledger implementation, we speak of consensus that do not consume energy in order to solve a mathematical problem, as it is in the Bitcoin case, to add a transaction on the network. We can have a consensus like elapsed time. What means elapsed time? It means that everybody that participates, so all the servers, have the right to add information on the ledger when the time that we have agreed elapses. So let's say that we have 10 servers on the network representing 10 different universities in our network. Then we say that the first one, it can be random, it's not a problem. The first one that adds a transaction on the ledger has to wait for 10 more minutes in order to add a second transaction. So this gives the opportunity to everyone, to every server participating in the network, to add information. In other cases, like the proof of work, because of the energy consumption, there are now many nodes participating that cannot even think of adding a transaction. And if we have time, in the end, I can explain why this happens. Nevertheless, consensus is different in every blockchain, and it can be any of these or even other consensus algorithms. So how blockchain works? I will just make a little bit zoom. I will zoom a little bit here so I can explain that. Everything starts through a DApp. Here is the initial action that you take. So a node, that means even a person using a decentralized application, initiates a transaction. Let's say that I want to issue a certificate to one of my students. And I'm an institution, a university, whatever, lifelong learning institution or higher education institution. I have to sign, to digitally sign, to be accurate, with my key, this statement that I'm issuing this certificate. So this action, issuing a certificate or a diploma or a degree to my student and adding my digital signature is the first step to send this record, this transaction, on the blockchain. In order to create a record on the blockchain, a block has to be created in order to represent the transaction. And if you understand, we have blockchain. So what this word means, it means that we have blocks that are chained together. So every block is a link on this chain, and I will explain a little bit more how this is done. So a block is created for every transaction. Just for your information, a block can contain more than one transactions, but for simplicity reasons, let's say that each block contains one transaction. So this transaction of issuing this digital certificate representing this transaction is created on the platform, whichever we have. And this transaction is then, as you see here, the third step, broadcasted to all the peers on the network. So everybody knows about this intention of the institution to issue this certificate, diploma, degree, whatever it is. So the peers here validate the transaction. What means validate? It means that do we have on the business logic an issuance from an institution to a student of a certificate? Yes, we do. Okay. Then is this transaction that we are here are presented valid in terms of it contains the right details for the student, it contains at least the, I don't know, the subject of the courses. So the data structure, is it correct? Yes, it is correct. Then after it is validated, so after we see the correctness of the transaction, this block is added on the blockchain. And you can see here that each block is connected to its previous one. So this is the way that this happens. Here, what it says, the peers nodes validate the transaction, is what we were saying before about the consensus algorithm. If any questions arise, please feel free to ask.
So you would like the questions to happen during your lecture?
Yes, yes, yes.
Okay, I have some questions, more to reconfirm some things. May I?
Of course. Please go ahead.
Thank you. Thank you. I would like to ask you the first question is like the security of the blockchain. lies on what did you say about distributed ledgers, so the information can be kept in the various nodes that or the various blocks that your network consists. So the security and the reliability of a blockchain is under this terminology, distributed ledger.
Yeah, a good question. Your question will be answered definitely in the next slides, but I will add two things here.
Let me wait. I can wait for the answer.
Okay. We will come back to this question. I'm answering this in the next slides. So here is the first kind of security, Konstantinos. What we mean here, sorry, just to relocate this window. What we see here is the difference with the databases. We said that you can think of the ledger as a database, but it is not exactly a database in the traditional way, because the ledger is write-only. So we are used in databases to have the create, also the update, and also the delete of the transactions, which we call records. Here in blockchain, we cannot delete anything. Everything is only written, is an append-only database and not a traditional one. So what does this mean? It means that it's tamper-proof. Nobody can go and delete a transaction. And you will say, oh my God, I just misspelled my name in the record or the student's name, and I added it on the blockchain. What will happen? Can I update it? Can I delete it? No, you cannot update it. You cannot delete it in the traditional way. But yes, you can, in terms of that you can add a new block, which will have, keep it in your mind simply because I don't want to delve more into technical details. It will have a pointer to the previous record, and it will say that it is invalid in terms of the misspelled name. So it will not be deleted. You cannot delete it, but you can update it by adding another record. And when someone will search for your name in the correct way, not the misspelled way, they will be presented with the latest record, the record that is in the block. But you cannot delete the previous one because everybody agreed that it is a valid record. It does not know what your name is. It just checks if your name is entered with letters and not with numbers. So if it is with letters, you can add whatever you like, but the system cannot check if the name is correct unless you have specific names that you accept. Well, this one thing of write-only prevents also the administrators from tampering with the database. So first step of security is that we do not let anyone tamper with the records. We have an immutable record, and when someone changes something, everybody will be notified. So if someone maliciously tries to tamper with a transaction, everybody will get informed, and the other nodes will say, no, this record is not this way. We have a different version of it, and you are a malicious user, so they will find that this is a malicious user, and they can either expel them from the network. Also, another...
Sophia, so
yes.
This means that all this information is kept at the beginning under the smart contract, no?
This is the feature of the blockchain as it is written as a network, not on the smart contract. The smart contract is the computer program that writes this information. So the smart contract is also a block on the blockchain. And we want to add there the smart contract because it is an agreement, and we do not anyone to tamper with this agreement. So we write it on the smart contract, is immutable there, nobody can change it, and when it triggers, we'll say later when it triggers in order to issue this certificate or degree, then it adds information with an append-only manner as well. The second level of security that we have is the permission versus the permissionless. We know the Bitcoin is a public blockchain, so anyone who wants to join can just join and even run a node. Nobody will say no to you. Also the Ethereum one. Now, this is not wanted by businesses. Businesses have secrets, of course, and interests, and they do not want to share their secrets with antagonists or with the public, of course not. So we have two kinds of blockchains. First, the permissionless and public ones. When anyone can join, we have a pseudo identity, or we are fully anonymized with just a number there. And you don't know with whom you transact with. You don't care with whom you transact with. But there are cases like the education domain where you want to know your customer. And your customer is your student, or it might be, I don't know, other universities in terms of not customer, let's say participants in your network. So you want to know who you're dealing with. And this is the kind of a permissioned blockchain. So we have an identity there, and we have a digital signature which is added in every transaction that we make. Do you remember that the initiation is the issuing of the certificate by digitally signing it by the institution? So the digital signature plays two important roles. The first of two is to identify the institution where someone wants to verify this credential that has been issued. And the second one is with the digital signing, you can also create what we call in blockchain the hash. The hash is a fingerprint. Think of it as a fingerprint of this transaction. So you have a unique fingerprint. Anyone can validate that you were somewhere by getting your fingerprints, okay? But they cannot form all of yourself. So this is the same in terms of transactions. Every transaction has a fingerprint, a unique identification, let's say, that whoever wants to find out if this is from this institution, they can, but they cannot recreate the information needed. So we have security by not disclosing information in the transaction, but by sending a fingerprint of this information, so a unique identification formed by that, and this is also mathematically generated, in order for someone to be able to automatically verify that. And this can only be done in private blockchains if you have been authenticated and authorized. So we have both authentication, identities, and also authorization, which means access. We get access rights to the data. I might be allowed to access some data, and I might not be allowed to access some other data. So depending on the role of me on the network, if I'm a professor, or if I'm a student, or if I'm the institution, or if I'm a third party, or a collaborative university, then I have some specific rights. So second stage of security in the permissioned enterprise blockchains. Now, it is important to understand, when do we need to have a blockchain and when not? So this is the decision path as it has been presented from research, and there are 7 specific questions. We will make it clear to you if you need a blockchain and if you need a public or a private blockchain, so a permissionless or a permission blockchain. The first question is if you have a shared common data, you need to share a common database with other participants. If yes, then you move on with the line. You also must have multiple parties involved. So if you are alone, you probably don't need, if I want to keep, let's say, my finances at home, I don't need the blockchain. But if I want to share maybe this information with my, I don't know, financial advisor, and we have conflict of interests, and we want to track each other's steps, then I might need a blockchain. Parties involved also have conflicting interests, or here it is, incentives, of course, and are not trusted. So we have to track what happened, and this is the way to do it with a blockchain, because blockchain becomes a single point of truth due to the fact that it is immutable, and this is also the security that Konstantinos Kostas before mentioned. So yes, also immutability is a security feature of blockchain. Now, you also must not have rules governing, you must have rules governing participants that are uniform. Also, you need, for an objective immutable log, you are looking for an immutable objective log. And also you have rules of transactions that do not change frequently. And this is something that in the past was a huge problem. Now we're overcoming it, because if you have something that must change regularly, then you are creating transactions, because even if you add a participant in the network, this is a transaction. If you make a decision through your decentralized application, this is a transaction. Whatever you do on the network, it isn't a transaction. It was a huge problem if we use the consensus of proof of work due to the energy, but also in the enterprise blockchains, it is also a problem because there are many steps that have to be done. First of all, to digitally sign. Second of all, to propagate the information. Third of all, to validate, come to a consensus. Yes, we've said that. So all this, and then to write on the blockchain, which is also a serial record, not a parallel recording. We will see then that every transaction has a timestamp. And when you digitally sign a transaction on the network, you also add a timestamp. So a hash, a fingerprint, the data structure, the information that you include, and also you have the timestamping, because it is very important to have the correct order of transactions. Let's think of an auction, for example, and say that there is an asset that we're receiving bids, and we have received the same bid from the first and from the third bidder, and we have a total of 5, and these are the highest. Which one should we accept? In terms of logic, if the agreement is that the first one that has the highest bid takes the asset. But if we do not have a chronological order to prove that it was first in the line, then we might have a problem with this asset. And also, the final question that determines if you need a public or a private blockchain is if these transactions are to be public or to be private. So if you're a business, an enterprise, probably this is not the question for you. You will choose the permission blockchain. If not, then you will choose a public blockchain. And I want to add here something. In the first implementations of blockchains in education, where the issuance of diplomas were made, the information was written on public blockchains. Well, you must consider GDPR. It's very important. If you write something on a public blockchain and you are in Europe, you cannot do that, because we have GDPR and the person has the right to be forgotten. So if you write personal information on blockchain, he or she cannot delete it, and you cannot delete it as well, because as we said, it's append only, and you can update it with a second transaction, but not delete the first occurrence. So what we have to think here is, of course, GDPR issues, but even on a private blockchain, we cannot add personal information on the ledger. So there are many techniques that we can do to overcome that, but this is a total new seminar by itself. How can we do that? Just keep in your mind that you must be cautious. So the first degrees, as I said, and diplomas were written on the blockchain. You can write them, you can write only the fingerprint, so only the hash of this information. And as we said, this information cannot be reconstructed in the first information that contained this transaction. But nevertheless, even this is not secure in meaning of technology might find something in the future that can decipher this information and I don't know, make out of it what it contained in the initial record. So yeah, consider GDPR issues here. And if you write something on a public ledger, now we just add an anchor. So if you are interested, you can search what an anchor is and find this technique to overcome the GDPR issue. Now, we've said about peer-to-peer networks. It's a network that every server communicates with every other server, and also the permission servers guarantee uptime. So we see here that we do not have a single point of failure, so additional security also here, and credibility, of course. And also we have communication links between all the participating nodes. Here is the terms of immutability, how the immutability is achieved on the blockchain. So I can zoom in a little bit. It's very technical, but I will just let you know how this happens. So let's say that we have 4 transactions here. Sorry, here, 4 transactions. Let's say that this is the issuance of 4 different certificates for our students. So student A, student B, student C, and student D. Then we have a level here that from this transaction, only the hash, so only the fingerprint is extracted from this transaction. And then we have here a fingerprint of 2 fingerprints and another one of the other 2 fingerprints. All these fingerprints are forming a last fingerprint, which becomes which comes from all these previous levels. And so what happens is that the block that is going to be written on the blockchain, so we do not write all of that, but this is represented by this one. So we can validate that even a small dot has changed in the information. This hash will be totally different. And think of it as a very big number, alphanumeric string, let's say, a unique alphanumeric string. So this hash demonstrates all these transactions in a way that nobody can get the information of the initial transaction, so no personal information here, and also a connection from this block to the previous one. So this is how the chain is formed. Previous block has an anchor, let's say a chain with the next one and the next one with the previous one, and etc. So if I change something, let's say here on this hash, then I remove it because I don't want this student to get a degree. I don't know, I'm a very bad person, but I do it. So this hash changes, and it is only the hash of A, B, and D. This block here contains the hash of this one containing all the letters A, B, C, and D. Can you imagine how we will find that this transaction has changed here? Can you imagine that by thinking of the chain? Is anyone who has?
So you are asking how you are going to identify any change in hash in block 11?
Correct. Correct.
I mean,
if I change here, I remove C.
Yeah, you can see it, from all the sequences of steps that, they are before, no? You mentioned that if we add an information in hash A, this will be copied in hash AB. If any change happens in A, this is reflected in AAB, and you can work in the reverse way now. So if any change happens in A, B, C, D, and alarm.
Correct answer, Kostas, but just half of it.
Okay.
Because the
I
other
need the help
one
of the audience.
is in the same concept, Kostas. It's in the same concept, yes. But who reconstructs this information? This is the key. Who sees that because on my server, and I will help you with that, I believe, on my server, I removed C. Who will find that I have removed it?
Transaction A, for example.
Yeah, I removed transaction A or transaction C on my server. How the network will understand that this changed? Okay, I will help you with that. So you can understand what decentralizations and redundancy of information means that we were speaking before. All the other nodes have this information as well. So they will see that mine block 12 is now different from theirs. And when we reached the consensus, we said that block 11 has A, B, C, D. Now I'm a malicious user and I say, no, only A, B, and D. And everybody else on the network, because they have the data before my change, know that I changed something. So they find out that I made a malicious change here, and they say that we do not accept it. So no consensus on that, and my transaction of block 12 that has been changed also because of block 11, because I removed C, are discarded. And as I told you before, they can either expel me from the consortium, from the participants. Now, I've said most of these things, so I will not stay in this, but if we understand that we not have any questions, we can see some use cases here. I will make a zoom so we can see them. Are there any questions for the previous slides? No?
I have some.
Please go ahead.
Let me also open in order now to consume some energy. So I would like to ask you, does the block that you have mentioned in one of your previous transparencies, and we can see it over there, is reflected by the digital portfolio that I'm going to create as a user to use blockchain? So my digital portfolio, I have to create a digital portfolio, am I right, in order to use blockchain? No?
No.
So I have no.
No. What I have to do is that we are, let's say, the universities of Europe. So we want to have a common network where we will store all our, I don't know, degrees of our students.
And
so
this can
that
be in a server?
In many servers, because we are speaking of decentralization. Yes.
Exactly.
Yes. So we have the need to store all the degrees of our students in a shared database ledger, as we call it, between us. We want everyone to have a copy of this data, so we will have the right to validate if these degrees are stored in the correct way, and we will not leave to enter this network any invalid data. And this is a network, a blockchain network.
Correct. But my question was like, the universities, in order to participate in this blockchain network, they should have a digital identity, no? You know, for example,
if it is, yes.
Yeah. Okay.
But not portfolio, because portfolio, in my mind, Kostas, is something different. If you meant identity, wallet, maybe?
Yes, wallet. Exactly, wallet. I don't know.
Okay, I will demonstrate the wallet in the next slides. And the wallet is, you can think of it, it can be or cannot be present in a blockchain solution. So in some cases, depending on your needs, you might need a wallet or not. In some cases, the only thing you need is to have the public and the private key to participate in a blockchain, in a private permission blockchain. So you create your identity on the blockchain issues, you can have other implementations, but let's say the simple one, okay? So you create the institution's username by its email, let's say, and the password. When you do that, and you say that this will run a server, a node, as we say, then a pair of keys is created for this institution. We also have some rules out there which say that this institution will participate in validating, so it will run a server, validating the degrees that we issue there. We can also have nodes that will not validate, but this is a more complicated solution. So let's say that every node, every server participates in the validation. So by that, you have an identity of institution X, I don't know what, a password, a set of keys to digitally sign the transactions, because each transaction, if you see here, has also a timestamp, which we said that it is the ordering, and also a digital signature, which is not displayed here, but we will see it in the next slide. So I don't know if this answers. It's not a wallet necessary to access the network.
I connected better now.
Great. I believe with the paradigms, we will even connect better. Do we have 1 hour or less? So I have to speed up.
What you have up to an hour, if you can. This is very good. Thank you.
You're very welcome. Well, I will just go here and see use cases. I will give you these slides if you like, so you can find all this information you can review this information on yourself and see most common use cases that are used. I will just say a few of them that are very important. Of course, we see here for cybersecurity reasons, we see here for education reasons, for the energy that we spoke in the beginning of this workshop, also for human resources or marketing or whatever. All these are use cases in the enterprise domain that we are using, apart from the financial sector, that we are using blockchain and specifically enterprise solutions of blockchains. So I will move now to the implementation of blockchain in the education sector, because it is important to understand in which cases we should use it, what we gain, and how we used it in our previous project. We will only delve into aspects because we don't have enough time to delve into all of them, but they are very, very important. First of all, it's the transparency. So blockchain can play a significant role in achieving transparency due to a secure and decentralized system. We said secure, it's about the identity, it's about the authorization, is because we have access rights, is because we have smart contracts that are written on the blockchain, demonstrate definitely the agreement which has to be followed in order for a record to be recorded on the ledger. And so the decentralization as well is transparency, because we can spot who tampers with the data. In terms of a database, on a centralized database, the administrator can tamper with the data and nobody will know that. But with the Merkle tree that blockchain is using, and by connecting the blocks to a chain, so if you change a link of this chain, we will know it, because everybody, all of us, as we said, have redundant copies of this data that you also had and changed. So the decentralized nature can store and manage the education records. We have here some of the reasons that transparency is enhanced by blockchain. First of all, as we explained, immutability. So by not altering and tampering with the data, we have integrity in the education records, and also prevention of unauthorized changes or falsification or forgery of the degrees and the diplomas. We also have secure credential verification, and that means that the degrees and the certificates and the diplomas that are stored on the blockchain can be easily and secure verified. Okay, so how can they be verified? This happens automatically because we have the hash, and I will show you in a next slide how this happens by comparing the hashes. So just one main concept, and I will say that again in the next slides, that the hash every time every time a hash is computed, if we use the same algorithm, then this algorithm always produces the same hash. So if I have the hash and you have you tell me which hash you use, then I can produce the hash, the fingerprint that we were speaking of before, that you have, and know that your credential that you are presenting to me, which is the block on the blockchain, has not been tampered. So what it is legal, it has not been tampered, so I can securely verify your achievements on whatever you are presenting. Also, the decentralization brings transparency due to the fact that everybody shares the same facts. We have a ledger at the same stage on every node, so everybody knows what's happening. And that's why we moved for the enterprise in permissioned and private blockchains, because we didn't want the public to know what we're doing, okay? But decentralization is still part of the private blockchain networks that we have, in terms that we form a consortium and the information is shared among us, so it is transparent what is there. There are just for you can search it on your time. You can search it on your time. There are kinds of private blockchain networks as well. For example, one is the consortium based. Okay, so it is semi-open. Search for kinds of private blockchains, and you can find the 2 or 3 different kinds. So the decentralization now is a term that we delved a lot into. What we gain is, of course, shared computational power, and of course we minimize or even don't have a single point of failure. The ownership and control of the education records are returned to the students. This has to do with the design of the application. I do not want to be absolute about that, but we can deploy blockchain solutions that can return the ownership and the control to the student. And through permissions, they can share the data with whoever they like. Also, the smart contracts automate the process. We have owners, sorry, this is the same one. We have the reduction of fraud, of course, because of the mutability of the server. We have cross-border recognition, because all over the world, if they're using a decentralized application, they can verify the record, the decentralized application we developed, of course. They can verify the credentials that we are presenting, the digital credentials we're presenting to them. And also we can enhance the data interoperability and the transparency through that, because we have a specific data structure that everybody who participates in our consortium-based private network has to follow. But just to say that regarding interoperability, it's not mine. I've heard it in a previous meeting, and it's correct. Interoperability is more a political issue and not a technical issue. In technical domain, we can achieve interoperability tomorrow, but it is more of a political issue that is presented like a technical issue. So if we have the agreement of everybody that will participate in a specific network, then interoperability is not a matter of blockchain or any other network, but it is a technical solution really easily achievable. Now, for the credibility and the accredibility, we have secure and transparency, and you will see some terms that are also here common with the transparency, because these are the main feature of the blockchain, and enhance credibility, accredibility, transparency, security, and whatever, the blockchain that we have discussed before. So immutable record keeping, of course, we can understand why the prevention of unauthorized changes is important, the decentralization, the transparency and accessibility, as you see, also enhances credibility and accredibility. We have instant verification, as we said, real-time verification through the blockchain with no intermediaries. And also we have smart contracts for the accreditation processes. I described one use case, the automatic issuance of ECTS points when someone completes a course. The permanent records of achievements, interoperability and standardization, I also explained that in the transparency as well. Student setting records, same thing here, also for credibility and accredibility. The reduction of accreditation fraud, so if we have smart contracts with specific agreements and nobody can change that smart contract, then when the conditions are met, the degrees will be issued automatically and nobody can change that. And also the cross-border recognition. So how does it work? You can understand here how does it work. So we see here that we have an issuer of an ID provider also. So let's say that is institution, educational institution, higher education institution, and then they have a verifiable credential that they issue to their student. So this is the user which holds the credential, the digital credential, and they publish a proof, let's say the hash Do you remember the hash on the blockchain network? So the anchor on the network. And what this user can do is when they go to a real-life party, this can be another university that this student wants to make a master degree after their bachelor that they received from the initial issuer, they have to present their degree there. So the verifier is presented with the verifiable presentation of the credential from the user, from the student, and they do not need, this is the secret, let's say, but now it's revealed, they do not need to contact the issuer. So this is really powerful because they can just go to the blockchain and verify that. How? You see here that by the hashes that they produce the same information. So the hash that is in this credential that it's provided to the second university is the same as the one that this issuer, the initial university, has written on the blockchain. So they convert the hashes, they are same, so it's verified automatically, and they know that this degree the student presents is legit. Kostas, you wanted something?
No, a colleague of mine said me bye. So
okay. Bye, colleague. Well, now
I have a question, if it's okay now.
Sure.
About
Please.
the previous
Yes.
slide. This one should be only between different universities, or it can be between the universities and, let's say, industry?
Yeah, any stakeholder. That's why we call that verifier and not university.
Okay.
Because even if you are an employer or I don't know what, whoever is interested in this information, then you can verify this credential. The only thing you have to do is to use the decentralized application in order to be able to access the blockchain through the DApp and let's say through your mobile on your desktop application, and then you can verify it. And if the question is answered, I can show you also some slides that will even contain the wallet feature that Kostas asked before, and also what Eli now asked about the verifiers. In the block academic project that we contributed and we developed a middleware there, the concept of the main platform, we were there with Aristotle University of Thessaloniki, Web2Learn, Ysoft, and also CERT, and specifically the ITI institution of CERT. So all these partners went to develop a blockchain ecosystem, where we had the block academic project. So what was this about? It was about 2-3 use cases. We will see here the main ones that are in correspondence with this seminar, this workshop. We had the university and also a teacher of the university, and we wanted not only to issue degrees, but also to issue micro-credentials. So the user does not only finish a course and gets the degree in the end of some courses, they also get some soft skills throughout their 4 years or 3 years or how many years they have, and throughout the various courses. So we have micro-credentials, we have soft skills, and how can we capture them? We had the LMSs, where the teacher here assigned an assignment, and in the beginning they said that when the student achieves this assignment, succeeds in this assignment, then they will have this specific soft skill. For example, they will have communication level 1, I don't know what, or research level 2, I don't know. Or they will have an algorithmic thinking. This is a condition. So these are skills that we captured through specific assignments. And when the student completed these assignments, the LMS captured the successful implementation of the assignment, calculated what they have done according to the conditions the teacher has set, okay? And then the LMS issued the micro-credential token. Here we added a plugin to do that because it was not in the Moodle, which we used in the end. And this plugin writes the micro-credential on the blockchain. So after that, the student could have in a wallet. So here we use the wallet. We didn't use only an authentication and authorization. We employed also a wallet with Hyperledger Indy. And this was the platform that CERT developed. And what they did here is to store also the degrees and also the micro credentials. So the student had all this information. And then I will just bypass that because it shows the concept of the verifier of the credentials. I will just bypass that because I explained it in the previous. You can look at it and send me any questions if you have, and go here to answer Eli question. So after that, the student could have this verifiable credential and send it not only to another university, which is, this case, institution A to institution B through the student, but they could send it to an employer who would like to employ this student or this alumni. So the verifiable credential was presented to the company, and the company didn't have to communicate with the institution in order to know if this is correct. They just contacted the blockchain single point of truth in order to see if the hash is correct, as we've explained before, and the record, let's say the record, and then say, yes, okay, this is verified, so the credential is valid, and I can hire you as an alumni. So this resolves the problem of universities or organizations or whichever institution issues credentials that goes out of business. If it closes, the student, the alumni, the person, the citizen wants to have these credentials for their lifetime. So blockchain can solve this problem and demonstrate that at that point in time, this credential was valid. Where to learn in this project contributed with a middleware, which we presented to all the institutions, the standards, because the lifelong learning institutions do not use standards to issue their credentials, most of them. So we introduced them with a tool, the schema compliance tool, where they could turn on by buttons the attributes that they use in their hard copy degrees or certificates, or in the digital ones, and compare them with a standard, a European standard, and see how much compliant are they with a standard. So here they could see that if I use only the full name, the last name, the date of birth, and let's say the name of the qualification of the conference and the access requirements, and something else, then I only have 30% of compliance with the diploma supplement standard. And also after that, we had three standards that they could make this comparison: the ECHO, the Micro HC, and the diploma supplement. And the next step that we moved forward is that we've told them, okay, you can create a hybrid schema. So take any attributes of these schemas, because lifelong learning institutions have different needs from the higher education institutions that they use the diploma supplement. So that we told them, okay, take 3 of them. So we introduced them to themselves and made them aware of the standards, of the European standards, and create one of your own. So you can use standardized attributes from all these 3 to cover your needs. So this was one of our other tools that we used. And the final step, when they created a schema, they could upload it on the blockchain in the main platform of a blockchain, which was developed by CERT, as I said, and there it would be end of time. Sorry, just give me 2 minutes and I'm concluding. And when this record was uploaded on the blockchain, then they could prove that at that time the schema that they used to issue certificates was this specific one created by Micro HC, Diploma Supplement, and ECHO. And this is the end of today's workshop. I don't know if you have any other questions, if you are still here.
I have questions.
Yes, Konstantinos, please.
My question is more to reconfirm what I have understood or not. So, I mean, I am a university, right? I'm a university, okay? So
Yes.
I would like to create with other partners, partner universities, a blockchain network in order, to share, let's say, I mean, a micro-credential, a degree that, we have a joint degree.
Okay.
And so myself as a university, I have to create somehow my digital identity, my digital wallet. Am I right? So I have to be identified. HMU has a digital number. I mean, in order to introduce to the blockchain application. No.
Well, I will say that because the wallet in terms of blockchain has a different meaning. That's why I cannot totally agree with that. So let's say yes, a kind of wallet to hold my identity and my private keys. A kind of a wallet.
All right, let's agree. I have my digital number as a university. I create somehow my digital number as a university, and the same happens with the other universities. So now, what do I need in order to create this? How do you name it? You name it the hash. So I'm creating, for example, some function that I place some regulations that in order a student to participate in this joint degree should satisfy, some activities. And when the student will satisfy these activities, then issue him with under, the data that you have shared with us, a certificate. That this certificate has a hash, that the student can use it afterwards, in the future, in his or her future career. So, I mean, I'm lost a little bit, I have my
just let me explain
yes.
First step, all the steps that you have to follow in order to have a blockchain network. It's not a long catalog, so not much time taken. First of all, you have to decide that you need a blockchain. So you have 2 participants or 3 or more. Then, as you said, you have a use case. I want to store the degrees there. The other thing that you have to do is, just let me go here, to choose from a blockchain solution. So you say, which of these blockchains are the right one for me, because a different blockchain network will form by Besu, another by Fabric, another by Indy, another by Sotu. Okay, so I choose then the technology that can serve the purpose I have. Let's say that we select the Hyperledger Hub, Hyperledger Fabric, which is the most common solution of Hyperledger. Then there we create a user account as you have it in any database. A user account for all the institutions, okay, one for University A, one for University B. So they will have an account as in every other system, in every other platform. And automatically, because this is how blockchain is, Hyperledger Fabric and is developed, has been developed. When you create a user there by saying, create user University A with that password, they automatically create the keys, okay? So the wallet that you say. So after that, there is a secret way. You don't know where this is. So that's why I don't call it wallet, because wallet, you have to access it, know where it is, and use this information. So this wallet is probably on a directory in the Linux machine. So you have your identity. With your private and public key, when you enter this network, there must have been already developed for you by developers the smart contract, so the business logic. So you say, with the universities, let's have some development teams, and apart from the users, which is the administration part, let's develop the solution. So we have the smart contracts. We say what exactly you said. I want to store that micro-credentials. Okay, what has to be done? This term, this term, this term. Okay, the developer does that. They have an account on the blockchain, and they make a transaction with smart contract. The smart contract is written on the ledger, and then with an application that they created for you, the developers, let's say on your mobile, when you press issue certificate, the code on the blockchain runs, and it issues the certificate. So you have developers that develop as any other way the platform and the functions and the business logic.
So that means we need the application. This is the blockchain is a technology, of course, and the way it works, and you mentioned that, and then we need an application to support the ideas. That's
exactly.
The decentralized application. Yeah, I'm just going back here so you can take a look at it.
Ledger. We need one of these applications in order to connect and create us, this communication. This is what I got.
So you see here, the users, which is you, have to use the DApp. Otherwise, you don't have access to the ledger, because the only thing that has access to the ledger is what? The smart contracts. And of course, the initial users, there are also other important aspects, the governance. So there are the administration parts and the development parts and the last user parts, as in every other application. The only change is that you have to use, of course, an application to access all the utilities of the blockchain. You do not directly access the blockchain. You must use the DApp, and the DApp contains, Kostas, what you asked before, how this hash is created. The blockchain as a platform, as a framework, it has integrated solution for that. So when you say that I have my wallet, as you have it on your mind, so my key, and I issue the certificate through my DApp, and in the background, it creates automatically the hash. You don't have to do it. It does it for you. This is also built in the solution. So if you use, for example, the Fabric implementation, it will create for you automatically a hash of 32 bits, let's say. If you use Iroha, it will create of a 28 bits, and etc. But the algorithm is built in the blockchain framework.
Yeah, correct. So these dApps are available, to the public to select what kind of dApp they are going to use, or if you have the capacity, you can develop your dApp. Am I right?
Yes. Most of these dApps are not available, because if you have a specific business need, then you have to develop your decentralized application. Yeah. A dApp, you can understand what a dApp is. If you have ever used Ethereum, for example, you have the MetaMask. So MetaMask is a dApp.
Yes. And so I suspect that the Erasmus without paper somehow works under the blockchain technology, in order to be able to...
It could. I don't know if they only utilize digital signatures, because the most mature technology and where blockchain was based are the digital signatures. So they can use it, or they will use it in the future in order for some immutable information. But some of the information, as I've said, is sensitive. So I don't know if they can move completely on a blockchain or partly. I believe the second.
Yeah. And in order to reconfirm something, so can we say that the blockchain is the highway in order to transfer microcredentials?
It can be used as a highway. For sure, it can be used as a point of reference to know the exact terms when these micro-credentials should be issued, and nobody can change the conditions when this happens. And yes, it can store them. But caution again for the GDPR, what we store as a micro-credential. So we don't store the user's identity. We can store maybe a number that represents the user, but not the user.
Yeah, definitely blockchain is not micro-credentials, because a lot of people say like I'm clear.
No.
Okay, thank you.
You're very welcome.
So Eli, do you think that we can create something like a DApp? I think we need to investigate that. We need to invest a little bit further. What we'd like to make it reliable. That means we need to make sure that the information is safe and we need to see if blockchain and the micro-credential is the right collaboration.
It can be combined.
It can be, but I think the big challenge here is to see what application will be available for that. And another challenge is what's the cost of these kinds of integration. I understand the blockchain, it's a little bit challenging.
Yeah, in terms of developmentally, of course,
Yeah.
but it's free. For example, hyperledger.org is open source. It's free to use it, and also the most common obstacle was the development teams. Not many people know how to develop dApps. Not many people know how to use it, and also not many administrators know how to support the servers. So these were the main obstacles. And in the beginning, as I've said, there were specific also programming languages. Now there are many common programming languages. In the beginning, they were not. So it was even more difficult. Now it's a little bit more feasible to do it and more understandable in terms of development. But you must have people who know how to write on a blockchain on a specific application of framework of a blockchain, and also you must have some administrators who understand or will learn how to support the network, because you have to run Hyperledger, for example, gives you out of the box by just running a Docker image that give you out of the box 4 ready servers that you can name University A, B, C, D. But if you want to have 8, for example, you have just to understand how to do that. And this is something that you have to delve more into. But I would recommend you at this phase to just go and find which framework you need for your case. And it depends, you remember the path for decision? See it. Yeah. So first decide if you need a blockchain, which kind of blockchain you need, and of course I'm here for you if I can answer any of your questions, even after the workshop.
Excellent. Excellent. So can I ask a last question, because we need to
please go ahead.
Keep the people. So within the dApp, which is like, you know, the heart of, I would say, of everything. It's like you insert the smart contract.
It's not the heart. Because the dApp is only the interface. The interface okay, that the user sees. The heart is the blockchain network. So the smart contract is written on the blockchain network, so on the servers, not in the dApp. The dApp calls. Yes, correct. The dApp calls the smart contract.
The blocks.
Yes. In order to interact and create blocks. So the application can be as easy as a button which says call create a certificate function. Yes. And it will call the smart contract called create a certificate, and the smart contract will interact with the ledger. Yeah. So that's the series of actions.
Thank you. I think I'm in a better state myself.
Great. Nice to hear that. I hope everybody is in a better state. I understand it is not a very easy concept. It has many new definitions. Every part of it, even the consensus, is a separate seminar. The governance, how the ledger works, what the smart contracts do, and how they are different from the functions that we are using. Every one of them are different, and all the other concepts. I understand it's too much, but I hope that you got the first step from this workshop.
Can we have the presentation?
Ellie, please.
Can we have the presentation? Or
Sure, yes.
Yeah.
Perfect.
Please send it to me. Yeah.
Thank you. And
I would like to tell you that the next blockchain seminar that we are going to introduce is exactly a dApp, like the EDU ECTX that University of Maribor had developed for universities to be connected. There is a question from our colleague Ioannis Barbounakis. What should be the series of steps necessary to set up a micro-credential dApp-based? Yannis, can you please ask the question directly? Okay. Let me read it. Hi, Yannis.
Hi.
From what I heard, let's say that we are interested as Hellenic Mediterranean University to set up a dApp distributed application in order to have a collaboration with some other universities and of course, issue micro-credentials and being able to validate among our institutions.
Mm-hmm.
Speaking technically, let's say we would like to have a number of steps, number one, step 2, step 3. Of course, with a few words, since we are at the finale of this presentation, where should we, where would we like to, how to start, where to ask advice for to start to understand the whole series of.
Yep, I understand, Ioannis. Your need and what you are asking. So it will be a small repetition of what I said before to Konstantinos, but in a different series. So the first thing that you have to do is to decide if you will use a public or a private. I believe private. So this is one. The second is which solution of the private blockchains will help you to implement what you would like. Let's say Hyperledger, which is the biggest one of all, and it's free and open source. And as well, universities, I believe that you support open source. So let's say that you choose Hyperledger Fabric. Then you say that Hyperledger Fabric is a stable solution because they provide out of the box SDKs to develop your DApp. So you have an SDK. So let's say that I have a development team that knows how to program in JavaScript. I have already a Docker image that comes from Fabric. So in no time, in I don't know, 1 minute, 10 minutes, I have a running network already. I don't need an administrator. So Fabric gives everything. And then I use the SDK in order to develop my solution with the DApp in a language my developers understand. So these are the steps, and if something is not clear, please let me know so I can repeat.
Okay, thank you. I think I'm okay with the answer. Thank you.
Great.
So, excellent. I think that we should stop here. Sophia, thank you very much. We appreciate it. We would like to thank everyone that participated in this discussion, in this meeting, and this workshop. Sophia, please share with me in order to share with the rest of the people the presentation. Sure. I will share with you through the Impact YouTube channel the whole webinar, the recordings, and we are going to renew our meeting next week with more workshops that we are going to organize. So again, thank you, stay safe, and speak to you soon. Bye.
Thank you, everybody. Bye-bye.
Thank you very much.
See you again. You're welcome. Bye.